Now that we've looked at how to predict the products in a double replacement reaction, we're going to look at what's called net ionic equations. Now, this is a technique that allows us just to focus on the pieces of a double replacement reaction specifically that actually react. And this is a technique that will carry through the rest of the course. So I'm going to go back and have a look at our potassium hydroxide iron 3 nitrate reaction. But what I'm going to do is I'm actually going to now represent each of the species involved as reactants in their dissociated form. So when 3 moles of potassium hydroxide dissolve in water, they represent 3 moles of potassium ions, 3 moles of hydroxide ions. Then we would have 1 mole of iron 3 ions and 3 moles of nitrate ions. If I then look at the products, I would end up with 3 moles of potassium ions, 3 moles of nitrate ions, and 1 mole of iron 3 hydroxide. You may also notice iron 3 hydroxide gets an S as a state symbol. It's a solid. All of the other players here are aqueous, as in they're dissolved in water. This is where the concept of net ionic comes in. Notice that on the left and right hand side of the reaction there's some duplicates. There are 3 moles of potassium ions on both sides of the equation. There's also 3 moles of nitrate ions on both sides of the equations. So if I was to go through and remove the identical species that appear on both sides, what I'm going to end up with is the net result of this reaction that occurs. So really what ends up happening chemically is I have 1 mole of iron 3 ions react with 3 moles of hydroxide ions to form 1 mole of iron 3 hydroxide solid. Okay, so this gets represented by what's known as a net ionic equation shown below. So a net ionic equation only examines the reacting ions, and then let's say the solid, could also be a gas, that is formed from that reaction. This is from page 292, I believe, of the Chemistry 12 textbook. You can have a look at this list of rules and some guidelines. I'd also advise you to read pages 292 to 294 on how to represent net ionic equations, as it's going to come up throughout the rest of the Chem 12 course.